Hey again, everyone. So we are going to diagram, we're going to draw on this sheet. We're going to make a model of the Earth revolving around the sun. And as you can see, it's blank. It's blank, okay? So the question is, can we create a model of the seasons and the axis and everything just on this, just with very, very, very limited information? And the answer is yes, we can. Because you know something about the Earth's revolution around the sun, and you know something about all of the planets' revolutions around the sun. When you're above the North Pole of Earth, which is the North Pole of the sun, in which direction do the planets revolve around the sun? Do they revolve around the sun clockwise or counterclockwise? You got it, counterclockwise. So we're going to draw in arrows on every section of the Earth's revolution around the sun. Oh, by the way, you should also have your ESRT pencil and maybe like a colored pen or something, okay? Definitely pencil, though. You need a pencil, okay? So we know that the Earth revolves around the sun counterclockwise when looking from above the sun's North Pole. Oh, by the way, if you want to, you can label this the sun. Okay. What we don't know in this diagram is in which direction is the Earth's axis tilted. So it's either going to be tilted this way, because we know it's parallel to each other, or that way. Okay, so what we're going to do is we're going to go with the Earth's axis being tilted in that orientation. So very carefully, what I want you to do, we're going to start over here. We're going to start on the far right Earth. Okay, we're going to draw in, if you want it to make it easier, turn it. We're going to draw in the North Pole and the South Pole. So we're going to label this NP and SP. Okay. Now, what is perpendicular to the North Pole and South, to the axis? What's perpendicular to the axis? That would be the equator. Okay, so we're going to lightly draw in the equator. Okay, and that's an approximate tilt. We're trying to model a 23.5 degree tilt. All right. Now, we know that the sun gives off light. All right, so when the Earth is in this position, that's the parallel ray of the sun. So the sun is directly over that latitude. All right, if the sun is shining on the Earth this way, then it's safe to say that this is the terminator. Okay, this is the day-night line. Does that make sense? Okay, so this side of the Earth is going to be shaded lightly. Please lightly shade that side of the Earth. Okay, so just to kind of talk about what we were doing right now, I'll zoom in a little to help. Okay, all right. This is the Earth's position. We're saying that we're going to make the axis tilt to from the left, top left to the bottom right. This is the sun's light. This half of the Earth is lit. That half of the Earth is dark. All right. Okay. So let's draw in the direction of rotation of Earth. From above the North Pole, the Earth rotates counterclockwise. Okay, so that's the direction of rotation. And the parallel rays of the sun. So what we're going to do here is we're going to draw the tangent line. Okay, a tangent is a line that hits a circle in one place. Okay, so I'm going to just draft this. I'm going to just draw this real quick. If this is a circle, the tangent to that point would be that line. That line, that straight line, touches that circle in only one place. If I wanted the tangent to that point, it would be this line. This line hits this circle in only that one place. If I wanted the tangent to that point, it would be that line. This line hits that circle in only one point. Okay, so that's a tangent to a circle, and I'll get rid of that right now. I just wanted to explain what a tangent was. Okay. At that point, that's the tangent. Okay, so what do you notice about the rays of the sun in this tangent line? They make a 90-degree angle. That means the sun is at this person's zenith. Okay, so what is this line of latitude? I know it's not to scale, but that line of latitude is 23.5 degrees north. Okay, sun is directly over this point. Okay, and what is 23.5 degrees north? What is that? What is the name of that latitude? Okay, this latitude is the Tropic of Cancer. Okay, tell me about who's in total darkness. Who has total darkness right now? Okay, everything down here. So Antarctic circle. Sorry, to South Pole. 24 hours dark. Up here, right here. Okay. Arctic circle to North Pole. 24 hours light. Okay. What date? What is the date of this occurrence? What is this date when the North Pole, you look at that North Pole, it's tilted towards the sun. That North Pole is warm and toasty. The North Pole is warm and toasty. This is the first day of the Northern Hemisphere's summer. This is June 21st, and this is the Northern Hemisphere's summer solstice. What is it for the Southern Hemisphere? It's the Southern Hemisphere's winter solstice, but we don't care because we don't live in Australia. We live in America. So America, it's Northern Hemisphere. That's what we're worried about, okay? Now, just from this one Earth, just from knowing that this is the North Pole and knowing that the Earth revolves in a counterclockwise direction, we can fill in everything else. Because if we go here, if this is the first day of summer, what happens 3 months later? This is the first day of the Northern Hemisphere's fall. So let's take that angle of the North Pole, South Pole, and let's transfer it over here. The North Pole is still tilted that way. This is still the North Pole. This is still the South Pole. The Earth still rotates that way. Okay, let's draw in the equator. Now, here are the sun's rays. They are directly over what? The sun's rays are directly over the equator. Okay, so on this day, the sun is directly over the equator. Okay. The North Pole is neither tilted towards nor away the sun. Okay, so the terminator is right on the North Pole, South Pole axis line. Okay. We have nothing to shade because this side of the Earth that we're looking at is completely 100% lit up by the sun. Where's the dark side of Earth? It's on the other side. We can't draw it. It's on the other side. Okay. Sun's directly over the equator. Everywhere on Earth, how much light, how much dark? Everywhere on Earth, 12 hours light and 12 hours dark. Okay. What is the date of this? This is usually September 23rd. It is the first day of the Northern Hemisphere's autumn. What's another word for autumn? It's okay if you want to say fall. That's fine. And what do we call this? This is the fall or autumnal equinox. Okay, remember, let's just write this down. Equi means equal, and nox means night. Okay. All right. So let's just zoom out, see what we got so far. So we're going from first day of summer, first day of fall. For the Northern Hemisphere. Again, we're focusing on the Northern Hemisphere because that's where we live. Okay. And let's go over here. Okay. All right. The Earth is going to continue to revolve 3 months after the first day of fall. Remember that axis. What does it stay? That axis stays parallel to itself. So the North Pole is still tilted that way. South Pole is tilted that way. Let's draw in the equator. Okay. Here's the sun's, it's a little bit too tilted, but that's okay. Here's the sun's direct rays. I'm sorry, that's lumpy. I'm going over the J-stand lump there, okay? All right, so let's draw in the terminator. Okay, this side of the Earth is dark. Okay, and the Earth is rotating counterclockwise from looking from above the North Pole. All right. So the rays of the sun, they're directly over what line? What special line is the sun directly over? The sun is directly over what's opposite the Tropic of Cancer. Whoopsie. Directly over 23.5 degrees south. And what do we call that? That is the Tropic of Capricorn. All right. And what else do we have to write? Okay. So if you look down here, see where it's completely lit? From the Antarctic Circle to the South Pole, it is 24 hours of light. And up here, from the Arctic Circle to the North Pole, there's 24 hours of darkness. Okay. How many hours of day and night at the equator? Still 12 and 12. Okay, so every single day of the year, the equator has 12 hours of light and 12 hours of dark. And the reason for that is the terminator and the equator. Whoopsie, let me zoom out. The terminator, well, this is the terminator, and the equator just pivot. They just pivot. Okay, so it doesn't matter what day of the year it is, the equator always has 12 and 12. Okay. So what is this date? What is the first day of our winter? Okay, this date is usually 12/21. We call this, in the Northern Hemisphere, we call this the winter solstice, not the winter soldier. Marvel fans, rejoice. Okay, it's the winter solstice. It is the first day of the Northern Hemisphere's winter. What do the people in Australia call this day? Well, they call this the summer solstice because this is the first day of their summer. Remember, our seasons are opposite. Okay? This is the shortest day of the year for us. I rejoice on December 22nd because the days start getting longer. Okay? Okay. So, first day of winter, we go through January. Okay, remember that over here, this is perihelion. And this usually happens around January 4th. And over here, this is this is about aphelion. And this usually happens around July 4th. Okay. All right, so we go through perihelion, we go through January, February, and this is, down here, this is the beginning of the next season. So again, North Pole, South Pole. Remember, axis is always parallel to itself. It's always pointing at that Polaris, right? Okay. And this is the equator. Okay. And here are the direct rays of the sun, and we can't see it. So what I'm going to do is I'm going to draw a dashed line because it's on the other side of the earth. But that's the direct rays of the sun. They're over the equator on the other side of the earth. Now, what we're looking at is the dark side of the earth because the sun is illuminating the other side. So very, very, very lightly, I want you to shade this in. So light that you could still see the equator and so light that you could still see that dashed arrow, that dashed line, okay? So very light, okay? So here, the sun is directly over, and remember the word for directly over, it starts with a Z. It is at the zenith. Okay, so if you're standing at the equator, the sun is at your zenith at solar noon. Okay, the sun is directly over the equator. For the entire Earth, everywhere on Earth, there's 12 hours light, 12 hours dark. Okay. That direct insolation is right over the equator, all right? This is what we call, in the northern hemisphere, this is our spring, or what we call vernal equinox. Okay. And this happens usually on March 20th. Remember, equinox equal night, okay? And this is the first day of the northern hemisphere spring, but the first day of the southern hemisphere is fall. Okay, so let's get back to what I was talking about before. Right here for the northern hemisphere, we're going to focus on us now. The northern hemisphere is tilted towards the sun. We are getting very direct insolation. The duration of insolation is very long. Therefore, the land masses and the water are heating up in the northern hemisphere. In the southern hemisphere, they're cooling off. This is the beginning of our summer. The insolation continues, although it's decreasing, but the summer months get hot, right? This is around the time where the insolation starts to really decrease. The direct insolation is over the equator, all right? Then we move into fall, into winter. Okay, in the winter, northern hemisphere, very indirect insolation, very short periods or duration of insolation. The land has time to cool off, the water is cooling off, and we get winter. Here's the tough months in winter, the January and February. These are the tough, cold months, okay? And then finally, the insolation length, duration of insolation starts to increase. The intensity of insolation starts to increase because the sun's higher in the sky. Spring, and then turns back into summer. And this, my friends, is why we have seasons. It's not the distance from the sun. It is the difference in the duration and intensity of the insolation that the different hemispheres receive due to the axial tilt and the parallelism of the Earth's axis as the Earth revolves around the sun. So you now are armed with this information. You can explain this to anyone who asks, why do we have seasons? This is the reason. All right. What you're going to do is you're going to work on these sheets, and there's going to be, you should have printed this out too. You don't have to print out the rest of the notes if you don't want to. And you're going to use this to help you answer these questions in here. And there's also going to be a few questions in Test Wizard. Okay. I'll see you guys soon. Bye.